great. OpenCV. What questions do you have? It's such a weird package. I kind of agree with the whole weight key thing. In order to show an image, you have to weight keys. Okay, so that part I can explain. If you had questions about that, can you read the line of code? So the previous line was OpenCV2.waitKey, right? Or CV2. Well, it was first IM show, right? So you first try to show the image. That alone is not going to make the image show. So you have to do CV2.waitKey. And okay, in that case, including one, that means what does that one mean? One what? 1 millisecond. So its default is to wait for a millisecond. Then there you go. So that's all you really need. First of all, keep that in mind. You could. What I often do is just to remind myself is I'll probably save that to a variable, and then I say like, let's see. Well, here, let's start with 0. 0 means waiting indefinitely. Wait until the key is pressed. Store that key in here. If the key is the same as this function takes a character and turns it into its corresponding ASCII int. And this key here is the ASCII int corresponding to the key that was pressed. So you can say if that corresponds with Q, then break whatever loop we were in here. Okay, or move on. This is probably in some sort of loop. No. Let's see. No, then this could be in a loop if you're doing video. Then it would break the loop there. And then after that, you would just break it. Okay, well what they did is they didn't do that. What do they do? Read the rest?
It's n
0xff. Right, and then was there anything else after that?
Yeah, it's double equal or
Yeah. Yeah.
this one, 21.
Oh, only one. Thanks. Okay. That's because, okay, so this is stupid. I don't know. It's not needed on big machines. What this does is, this is a bitwise AND operator. This means whatever character wait key returns, it's a number, right? It's an ASCII number between 0 and 256, 255. That corresponds with a, binary value, 0, 1, 0, 1, 0, 1, 0, 1. Let's say that was it, okay? 0xFF, that means hexadecimal FF. Hexadecimal FF is 16 times 16 minus 1. Because it's 15 times 16 plus 15. That's 255. In binary, that's 1, 1, 1, 1, 1, 1, 1, 1. It says bitwise AND these. The AND is 1 and 1 is 1. 1 and 0 is 0. 1 and 1 is 1. 0, 1, 0, 1, 0. It's whatever this was. It's whatever wait key returned. This AND 0xFF doesn't change it at all. I don't know why they did it. It doesn't change it at all, so just don't do that. It makes a lot more sense if you see if the key that wait key returned is equal to the ASCII character code corresponding to Q. So I don't know why they wrote that. It could be that they were doing, like, if this is already the right data type, then it will do nothing. Maybe this was some, sometimes you multiply by 1.0 to convert to a float. Maybe that's the idea. Otherwise, I don't know. I don't know what they were getting at there. Because, it's probably a holdout from C++. It's probably something, an idiom that they use in C++, but in Python, there's not different data types that wait key would return, so I wouldn't worry about it. Yeah.
So when I load the video, so the phone comes early, so where I need to load the
When you load the video, it becomes gray. That's what you said?
Yeah.
Well, I think that So if you're talking about the video, if I remember correctly, when you read the frames, they're typically red in color, and then you converted it to grayscale using a different function.
Yeah.
So if you don't call that function, then it won't convert it to grayscale, and you can just show the color image.
No. But like the emission takes like 2 arguments, so if I don't. Yeah, the thing is, this need 2 arguments, so I have to put something here.
Just don't call that function.
Yeah,
Put in frame. Yeah, instead of gray. So just don't call the function. What is gray? What is frame? They're NumPy arrays. So provide frame, the full, 3-dimensional one with the color information. IMShow will take either of them. Yeah. Explain the difference between threshold and range, in range. Was it a threshold function? Yeah, okay. I think the threshold, yeah, can you give me an example called the threshold, and I'll explain what the different numbers meant. CV2.threshold. What were the arguments? We had to provide the image, we had to provide like the maximum value, what to replace it with, yeah. Are you sure it was the minimum value? The threshold value, right? Let me see the call. 0, 2, 5. Oh. Okay, I don't think that this number is supposed to be 0. Let's look at that one, 127. 255. And then there was like a method. What was CV2 dot? There was like CV2 dot something, some static constant or some constant. Okay. So this is a call to threshold. What it's going to do is it's going to take a look at all the pixels in the image, and it's going to say if they are less than 127, make them 0. If they're greater than 127, make them the maximum value, 255. So it takes a look at this value, and this is the threshold value. If they're above it, they go to 255. If they're below it, they go to 0. It assumes that the lowest value is 0. You have to tell it what the maximum value is. This thing here is an additional option, and there are a bunch of constants that you can look at. So if you look at the threshold function, you can look up what these different options are. One of them would be like to invert it. So it could actually change the behavior. The usual behavior is for if it's below 127, go to 0. If it's above, go to 255. You can also invert that with one of these options. You know that. Otherwise, if you just need whatever the behaviors provide, whatever value they typically tell you. That's different from in range because there was CV2.inRange. Can you give me an example call of that? Well, let's describe it conceptually. If this is your range from 0 to 255, and here's your threshold of 127, it checks which side of it you're on. In range is actually looking at color data. Typically, I think it looks at 3 channels of color simultaneously. So now we've got really 3 number lines corresponding with red, green, and blue. Oh, wait, isn't it actually blue, green, and red in OpenCV? Right? You might have discovered that? Yeah? Okay. So this is 0 and this is 255. Then when you say in range, you're going to provide a lower threshold, like here, and an upper threshold on the values. And it checks whether all 3 of them are within that range. Color value. And we'll turn 0 if true and or false, 0 if it's not, and maybe 1s or 255s if it is. 255 means the same thing as 1 when we're talking about a binary image, right? It's just one or the other. The concept is on or off, usually. Did that answer your question about the difference? But you can accomplish both of these things with pure NumPy, right? I suggest if you don't like these functions, and I don't love them, because they're I think they're a little too cumbersome to work with, you can do just this with NumPy. You can create, you can do a comparison. You can check, image is less than 255, or excuse me, 127, right? Well, that's not going to give you exactly the array of zeros and 255s that you want. It's going to give you an array of trues and falses. But the falses are in the places where zeros should be, and the trues are in places where 255 should be. So I'll let you figure out how to turn that into an array with zeros and 255. So that can quickly replace threshold. And then you can use kind of the same concept for this one as well. But this does a lot of work for you, right? Because it checks whether it's in the range for the blue channel, and it's within range for the green channel, and within range for the red channel. So that's actually 6 separate comparisons, because you have to check whether it's greater than a certain value and less than another value for 3 different colors. So you certainly could do that with NumPy, but this kind of is a shortcut. So I'd say that this is worth using. But thresholding can be done in basically just using the lines of NumPy. Yeah.
So when it's talking about drawing contours, it said that we should apply a threshold first or use candy edge detection. What is specific?
Okay. Well, in order to use candy edge detection, typically you also binarize the image as well.
Okay.
So candy edge detection. All right. What's the difference between them? I'm not going to be able to draw very well, actually. Let's see. Well, let's. I think I can only just describe in words. I'm not going to be able to do it justice with this pen. I don't want to write a million numbers out with this pen, so it's not going to really make sense. The algorithm for contours is designed to work when it's very clear where there is something and where there is not something. It's a lot easier to tell when it's ones and zeros than if it's different shades of gray. It's a lot easier to recognize between black and white than it is when something morphs into different colors and all that. Okay, so you can kind of understand why something that's designed to detect contours or recognize the perimeter of objects is easier to do when it's already been thresholded, when it's already been binarized somehow. That's why I suggest using thresholding. Candy edge detection is actually kind of similar to contours in that it's supposed to recognize the edges around objects, but notice edges are not the same thing as contours, because edges don't have to be connected. They don't have to be closed. Contours are always closed. And so I think that the contour function can take the candy edge data, so like let's say your original image is this. I guess I have to do this. Here we go. This is the 1, and 0. Sorry. So this came from, we did a thresholding and came up with this. Because it was originally grays, and we said, all right, well, this is where it was darkest, and this will turn into white, or vice versa, right? What contour is going to do is it can take this and directly tell you the contour is around here. Ooh, shoot. I want to add some additional zeros inside here. All right, so pretend that there's a lot of other numbers in here that aren't being shown. Okay, here we go. So we binarized and we came up with this. This is what contour is going to do. Candy edge detection is probably, well, let's see. That's going to find where the transition between the ones and zeros were. And so it's actually going to return something. It's like the edges were here, and it's going to return ones and zeros like this. And contour can also look and find those ones and find it. So don't worry about candy edge detection. We're not going to talk about it. But the point is the difference. It needs to be thresholded. It needs to be binarized, zeros and ones. If if you just do the thresholding, you'll probably end up in a solid block wherever the objects are. If you did candy edge detection, it's already only going to tell you the ones where the boundaries of the object were. And the contour function can work on either of those. Candy edge detection is cool. That's another thing you could play with an OpenCV. Also a very useful function. So over the summers, the past 2 summers, I've done a little bit of research with undergraduate students on analysis of data from body-worn video taken by the LAPD, because a lot of them have body cameras now. And so the first summer we were looking at the problem of primarily detecting whether the officer was running or walking. And I think we used OpenCV. We might have used MATLAB that summer instead, but it's basically equivalent phase. And so there's routines that OpenCV has and MATLAB has as well that will detect from frame to frame of the video. It tries to estimate how pixels changed, where they moved to specifically. That's called, oh my gosh, I'm just having a blank. Somebody knows what I'm talking about? The vector field you get. Optical flow. Optical flow, it's trying to say like, all right, this red pixel in the next frame is over here. And so I can draw a vector for there. So for basically every pixel, you can detect where that pixel moved to, approximately, right? Because some of those pixels moved off screen, it doesn't know where those went. It's very difficult to tell sometimes what pixel corresponds with another pixel, but roughly it can do that. And so what we did is we find those vector fields corresponding with how the pixels are moving, and you can imagine that if the camera is simply translating this way, then all the pixels are moving that way, right? And if it's going up and down, vice versa, if it's rotating, then you're going to have like a circular vector field, right? And so you can kind of decompose the vector field you get into the sum of a bunch of different vector fields corresponding with the basic motions of the camera, assuming that that nobody else is actually moving in the frame. Right? So you can basically decompose what's changing, and assuming that most of the changes are due to camera movement and not due to actual movement in the scene, you can decompose it into how the camera was moving, and based on how the camera was moving, you can determine whether the officer was running or walking. It wasn't perfect, but that was our attempt. But that's something, for instance, you could do with optical, with OpenCV. Another thing done with OpenCV, we have a robot project that we were working on over the summer. We had an overhead camera, and we were doing this object tracking, basically drawing contours around where the robot was, and tracking where the robot goes over time, so we can report the data. So those are some examples of how OpenCV, this type of stuff, can be used. Yeah?
Well, so I was just curious, how did you guys get scale? So like, how do you know?
Scale is difficult to determine.
Yeah, but how did you know if you were running? Like, how did you get speed?
Mostly, it wasn't really speed. We didn't look so much at the Z movement. We looked at the up and down direction, and the frequency of walking is lower than the frequency of running.
Okay.
But we used machine learning to give it some data for this is what one officer's gait looks like, and this is what another, running versus walking.
Oh, cool.
Yeah, mostly frequencies, I think, is how the machine would detect it. Yeah, I think we turned a bunch of those signals. We did the fast Fourier transform on those and gave that data as features. And we'll see what I mean by features in machine learning next time, because that's the next assignment. Oh, before I forget, let's see, a few things. If you haven't signed up for the last day of class, I was thinking about having a hackathon. If you want to participate in that, if that sounds fun to you, that means like everybody would come up here and make about a 1-minute pitch as to what program they want to write, and they want to try to recruit other people to work on it with them. And then for the course of the afternoon, whatever time you had in between classes, you come back to the PIC lab until it closes at 6 and work together on these little projects. So if you've got an idea for a project, or if it sounds fun participating with somebody else on writing a cool program, getting a little bit of extra credit, on the last day of class. That was the plan because I don't have additional material. I'm not gonna have you do an assignment that's due sometime during finals week. So the idea is to finish up whatever you're assigned on Monday, or we'll get to that in a second. The idea is to finish up everything for the course by Friday, and so that Friday you could, so please fill out that survey. I've sent 2 emails about it. Tell me what times you'd be available. Another thing, extra credit. If you do the course evaluation, you get 1% extra credit out of the 100% course grade. And the reason for that is I think that that's the maximum I'm allowed to give you. And I think it's important because not only does it give me feedback, but part of college is not only learning, but learning how you learn. So part of that process is knowing how you learn best and assessing what went well in this course, what didn't. Reflecting on that gives you a little sense of how you learn and how you learn to learn. So spend some time thinking about that as a point. I want to incentivize that. And other thing is, class next week, because, so this weekend, the PIC lab is closed all weekend. So the assignment that you do today, which is easiest done on a Windows machine, you're not going to be able to do here in the PIC lab. So I'm going to give until Friday at the end of next week to finish it. That doesn't mean, there will be an assignment next week that's also due Friday, but you're going to have an extension on this homework. And the final thing is that in order to give you more time on next week's assignment, right, today is Wednesday, because Friday is off, you're supposed to have your next class on Wednesday. That would leave you only 2 days before the Friday to finish up the assignment. I want you all to come to lecture on Tuesday instead of discussion on Tuesday. So I'll have a Monday lecture, that will be track B. And we'll have a Tuesday lecture for track A, and then Wednesday and Thursday will both be discussions. So because I'm the TA and the professor now, I can do that because you're supposed to be here anyways. That was 4 quick announcements that I don't want to forget. I'll send emails about these different things as well. Other questions before you take the quiz? Last chance. All right. The password is, I think it's all lowercase. Run, Forrest, run. And that's 2 R's in Forrest, because that's his name. And the reason for that is because the assignment for today is going to be detecting the running gait of a person. You're going to be tracking their hip. In a video of them running, you're going to be tracking their hip location. You're going to see how it bounces up and down the sinusoid as they run. His name is Ryan, not Forrest. It does. The name does.
Is it capitalized?
No, there's no capitalization. It's all be lowercase. Run.
Oh.
Is that stapler? Oh, okay. Do I need both sides? You want to turn into the flash? Oh, I see.
It's part of the
I see. Yeah, I don't think I need this unless
Did I ask you to check off things?
Not entirely.
No,
mean,
I don't
if
think I did.
Okay,
Don't worry about that. You can just turn this in and write your name on it.
okay.
Yeah, it's really short and there were a lot of instructions.
Well, I had a.
You know what I think I'm gonna do? Is I'm gonna move this up to the first page and then be like, here's a bunch of other information if you can't figure this out.
Well, I pitched more idea. I'm not gonna do this on this as long as there is explanation. But it's past 142 and we have to do a project with after this identical
Problem?
system.
Yeah.
Doing the first order system, so then like that fast. I think you're trying to explain that
How
aspect.
is? Yeah,
Because then after you do that, then it's just like, oh.
yeah, it's really short.
That's why I didn't like that just not here, but I just didn't like do it.
No, you're fine. I mean, if you got a block list like this, that's all it takes. Yep.
It's just like so long. It's like, oh my God.
I realized that a lot of students would mention that, so I think that's the whole.
But I do understand like having seen that.
It's really confusing,
Yeah.
to be honest.
Oh, I went to my teacher's office after 4 times,
Yeah.
like, and we looked at it and we looked at it and
Oh,
finally
yeah.
sunk in.
Yeah, it's
And
tough.
like when you helped me the other day, when you were trying to tell me that it optimizes the whole original type array, and I didn't get it, and I know I kept saying yes, and I didn't get it.
Yeah.
I actually slept about 5 minutes after you left, and I like walked outside, and then it hit me. Out there.
Perfect. It's good to have that realization.
Except then I'm like, I'm
Somehow
not
it's hard to express, but I'm glad you figured that. It's very
You probably
similar.
could tell you just went yes, and then, you know, it wasn't again with yes. Sometimes you just have to give me as much explanation as you could offer at the time. It happens.
I understand.
Luckily I was able to come back, so I just like uploaded the assignment, but
All right.
thank you.
Anybody still working on the quiz? Questions, you have them on the quiz? Yeah? Yeah.
Right.
Well, first of all, that was, all right, go ahead and work on the assignment.
Wait, hold on, I'll show you my pen. Oh, yeah. For real. Been a clever pen since I was in red. All day. Watch what we do after they don't think they want you. The problem is that like they can dominate the board, they can dominate the board, but like who the heck cares? No, you can't defend against a team like yeah, but they're not fast enough. They're not fast enough. No, I mean within fast enough. Yeah, you have to. Yeah, you just hope it dude, look at the top 5. Look at the top 5 players. Laker, alright. Chris Paul, really good. DeAndre, pretty good. Paul Pierce, nice. Exactly. Jamal Crawford, good. Yeah, he's like 80. Yes, space. What the heck is space gonna do? Austin Rivers, so what is he gonna do? Brian Good, I think it was Bryce Johnson.
That's a different concept. You need to remember the name, you need to remember the no, I can call it an object and call a method on that object.
Wait. We have Raymond Felton. Oh my god. Oh, garbage. There's no reason this team should be doing this. Oh, we have Raymond